The first one we're going to go to is RNZI, Radio New Zealand International, shortwave site. Unfortunately, we won't be able to see inside the transmitters because they're going and we can't take them off. And we won't be able to get close to the antennas, but they're large antennas anyway, so you'll see them. But there are some safety issues. Don't go climbing any fences. There's a fence, a compound around the antennas. There's some radiation issues and some voltage issues inside the fencing. So don't go trying to open any gates or climb over to get a closer view. Inside the transmitter building, we might have to break into about 3 groups. And I can take one group at a time inside because there was a lot of room, but now with the second transmitter installed, there's not a lot of room inside. I have some photos of the inside of the transmitters, which you might be keen to look at. Everything with these shortwave transmitters is big. Coils are this size, and they have water running through them, water cooled. So it's quite, the internals of the transmitters are actually very, very interesting from a number of point of views. And I know the Rotorua hams had, about 5 years ago, had a trip, and it was a maintenance day, which is a Thursday, and they were able to see inside the transmitters. It's quite impressive. But anyway, I've got some photos to show anyway. The second site, which is back further this way, is the marine telco radio, and the transmitters are somewhat smaller, but the antennas there are quite unique. It's 2 HF spirocones and a log and a dipole, so they're sort of quite unique type antennas. So I think that's about it. As far as the safety goes, inside the transmitter hall there is an area that we have to avoid. I'll show you in the smaller groups. We're not to go inside there.
Before we do that, I'd like to say thank you very much to everybody for coming along. It's always good to meet your neighbour. I noticed 2 minutes ago that Peter had his hands in his pockets, and I thought that's an excellent place to keep them all day, because you won't get a second chance at getting bitten by some of these volts. We'll spend about an hour on each of the 2 sites, and then we'll head off to the cabin that's up the road there. Some of you would have seen, and obviously there's going to be an issue with feeding everybody at once for those that are coming, so just cruise through and sit around and tell lies and whatever we do, and think above all, enjoy the day, and in advance, thank you very much.
No, I appreciate it. I think there's obviously a lot of interest, and it is quite a unique site for New Zealand anyway. The RNZI, I mean, it is the only broadcast shortwave site in New Zealand, and by world standards, the transmitters are quite small, 100 kilowatt. A lot of the installations in Guam and North America and around Europe are 500 kilowatts or even larger. It was actually quite difficult getting hold of transmitters so small when they purchased these Tomcast transmitters. And the islands continually have problems getting hold of transmitters in the likes of 10 to 20 kilowatts. There's not a lot of companies now make transmitters. And they're still valves, yeah. Both transmitters, even the new transmitter that was installed in 2006 has a valve final, triode, water cooled or steam cooled actually. It is steam radio. Saying last night, to Ted, the final, the tubes are worth about $40,000 US. And it takes 2 men and a hoist to lift them. Carefully.
You won't take a shang on.
I think we can walk from here. Hello.
I mean, why go and buy it when you can make it for nothing? Yeah. You owe me.
Antennas made simple.
Some big spiders and like that.
Okay, yeah.
Spider web there.
Yeah, what's this body? Yeah, every
Well, they're low flying anything actually.
Well, I'll only do it once.
An aeroplane caught up in the web.
I bet the odd one does.
I'll gather eventually.
Okay, now the basic concept of the antennas is they're curtain antennas. It's a series of dipoles with a curtain as a reflector. It's set up in the compound as a V facing north. So that structure out there in the distance, standing behind us, we're not quite behind the whole thing, but particularly north is straight out through here, and the V faces north, and by a series of switches in the paddock we can feed each curtain by itself or the two outside together depending on the frequencies. So with the two in the middle fed, those are what we call a high band curtain. They operate from about 7 megs up to around about 18 megs, and when they're fed both equally it's 0 degrees. So fed equally 0 degrees straight north. When the power is applied just to the right hand one it's 25 degrees, and when it's applied just to the left hand one it's 270 degrees. Likewise with the two outer ones, they're the low band curtains, and they operate from about, well, they only operate from 5 megs, but they will operate down to about 3.5 megs up to about 12 megs. There's a bit of an overlap in the middle. Some frequencies are a slightly better match than others, so there's sometimes a bit of a change depending in the middle there between about 7 megs and 10 megs which antennas are used. For the most part though, they radiate due north. The key market is the South Pacific Islands, even though coverage is pretty much worldwide. I mean, I've been in North America and Alaska and listened to the service from here, dogs, but their programming is focused on the South Pacific Islands, Solomon Islands, across to Fiji, Vanuatu, Cook Islands. That's the key market. The digital transmitter, the digital is not really designed for broadcast. It's designed to link programming through to the islands, and then the islands take the programming, record the programming and repackage it, and then rebroadcast it on their local FM or AM stations on the island.